A very good morning to our lecturer, Mr. Muhammad Nazin Shah. My name is Nawanida Anlaki Toyraj. My matrix ID is 211291020. Today I will be discussing about Lab 1, which is Introduction to Simulating and Open Loop Systems Characteristics. So as you can see, the objective of this lab is to illustrate the features and the use of software developed for computer-aided control system design and analysis, in this case the MATLAB or Simulink software. So the task for this lab is to draw a model consists of 3 blocks, which is step, transfer function and scope as shown below. So as you can see, this is the step, this is the transfer function and scope. So this is the task. We have to use this number to find the results. Now let's go into MATLAB, whereby I have already opened. So let us demonstrate step. So with step, we'll be placing it here. Then we'll be going for transfer function. Choosing this one. Then we'll be choosing scope. So then after placing scope, we have to connect the wires. So let's make it bigger. Okay, for step, we have to do some changes whereby the step time should be 0. Then for this, I would like to demonstrate this one, 9 to 9. Let's check once again. S square, 2s and plus 9. So this is the scope. So what you have to do is simulate, and after simulating we have to, so this is the graph. This is for the first one. So what we can do is we can go for the second one. Okay, so for the second one we can go for this 625 s square plus 625. And this one will be placing it under 0. 625. Let's double check. 65 s square plus 65. 65 s square plus 65. So we'll be simulating it, and with that, this is the graph. So now let us move on to, this is the result, which is for task 2.5. This is the result for 2.6, 2.6b and 2.6c. And as for discussion, in this experiment, the capabilities of MATLAB or Simulink for computer-aided control system design analysis focuses on open loop system were explored. Okay, the relationship between the transfer function and the resulting graph or signal is crucial in understanding the system behavior. The transfer function, represented in Laplace domain, defines the system's characteristics and its response to different inputs. When we apply a step input to the system, the Laplace transform transfer function is multiplied by the Laplace transform step function 1 over s to obtain the Laplace transform output. Inverse Laplace transform of this product gives us the time domain response, which is what we observe on the scope. As we examine 3 different transfer functions, which is A, 9 over s square plus 2s plus 9, and for B, 625 over s square plus 625, and as for C, 10 over 2s square plus 3s plus 5. We witness how each transfer function uniquely influences the transfer system's response. Specifically, the transfer function's poles and zeros dictates the system's behavior. The location of poles in the complex lane determine the system's stability and transient response. A higher number of poles in the right half of the complex plane indicates a less stable system with oscillatory behavior, while the poles on the left half suggest a more stable system with smoother response. Now, for conclusion, this experiment has not only introduced us to the practical use of MATLAB or Simulink for control system design and analysis, but also illustrated the fundamental connection between transfer function and system behavior. By simulating open loop systems with various transfer functions, we gain insight into the significance of poles and zeros in shaping the system's performance. The results displayed on the scope, whether indicating stable, oscillatory, or other response patterns, were a direct reflection of the transfer function's characteristics. This experiment lays the foundation for further exploration of control systems, paving the way for a deeper understanding of how to design and optimize systems for specific applications based on their different transfer functions. It also highlights the importance of choosing appropriate transfer function to achieve the desired system behavior and performance. So now let's move on to open loop system characteristics objective. To illustrate open loop time domain responses of first order and second order system using the transfer function. To illustrate the difference of output from open loop response with ramp, step, and impulse input. So as for this, we'll be conducting a small experiment whereby I'll be using this as an example. Let's go for step. So I'll just copy paste this. So I'll just delete this because we got 3 and we need mux. Okay, so we need 3. So then we'll be going for this, we're going for this, and we're going for this. Okay, then we'll be focusing on this and that. Sorry. So we are going to change the values inside that. 2.5, 1, 10, and 50. Okay. Let's go for double checking. S plus 1, 10s plus 1, 50s plus 1. For a better picture, okay. And 1. 2.5. 50. This 1. And let's apply. Okay, correct. So now let's simulate and we can see the graph. So this is for a step impulse, and now let's go for, so this is the one step input. Now let's go for ramp input. Simulate again. This is for RAM. This is the RAM input. And lastly, we're going for the impulse input. So for impulse input, we have to cut this and insert step again. And between that, we also need to include derivative. Between that, this will be going for 0. This will be 1. So this is the graph for ramp input. You see this is the impulse input. So as you can see, I have demonstrated that for step input, ramp input, and ramp input, impulse input. Okay, so as for discussion, in this experiment, the primary objectives were to explore the open loop time domain responses of the first order and second order systems using transfer functions, and to observe how the system respond to various input signals, including unit impulse, unit step, and unit ramp. So in conclusion, the experiment provides valuable insights into time domain responses of open loop and control system. The key findings can be summarized as follows. For the first order systems, time constant and gain pivotal roles in shaping the system's response. Time constant dictates the system's speed and level of damping, while the gain impacts the amplitude of response. Different input signals reveal specific aspects of behavior, making it possible to understand its dynamic and characteristics comprehensively. So I guess that's it, and this wraps up for lab 1, and thank you for listening. Have a nice day.